Very much. Welcome back to CHE 451 Chemical Process Technology Module 4.1. We're going to look at mixing and agitation. My name is Professor Engineer JC Igwe. So we're going to look at introduction, we'll look at applications of mixing and agitation, look at some agitation methods, characterization of mixing quality, and then conclusions. Introduction. Mixing is a random distribution into and through one another of two or more initially separate phases with various degrees of homogeneity. So we talked about mixing in class. Remember when I gave you an example and said if you want to mix, probably you're doing a tea, you've added milk, something like Bonvita or Milo, and you have also added your sugar and any other thing you want to add, maybe honey or something, and then use your spoon to stir it. You are trying to mix all the components to get one homogeneous mixture so that from any angle you're drinking your tea, it will have the same taste. On the other hand, agitation is a means by which mixing of phases can be accomplished and by which mass and heat transfer can be enhanced between phases or with external surfaces. So agitation is another type of mixing, but different. Just like we say, it is an induced motion in a material in a specified way, usually in circulatory pattern. So if you have used an agitator before, you see how it kind of bumps and then causes mixing. Of course, agitation is also a unit operation, which is used to bring into contact two liquids mechanically in an agitated vessel. So agitation and mixing is still a means. That's why I say it's a unit operation. It's still a means of bringing different phases and make them to achieve one homogeneous phase. Applications of mixing and agitation. Dispersion of solvable solid, that's one. Applied in homogenization of miscible liquids. So miscible liquids can be homogenized to get one homogeneous mixture. Mixing and dispersion of immiscible liquids by forming an emulsion or suspension. So we can use the mixing and agitation to achieve this. Mixing between gas and liquid, suspension of solid particles in a liquid, acceleration of chemical reaction and physical transport. Because while we are mixing also, there will be mass transfer, even heat transfer, and so on between the phases. Enhancement of mass transfer between dispersed phases. That's why if you have something like a syrup that will give to children, when you leave it after a very long time, they ask mix before or shake well before you drink or before administering. That means if you look at it when it is settled for a very long time, you see that there's always a kind of separation. You see some different phases. But when you shake, that means you have mixed the phases well to have a homogeneous syrup which can now be administered. There are agitation methods which can be achieved by mechanical agitators, gas agitation, jet mixing. Jet mixing like a jet. If you open your tap and you're using a hose, when you open to the full turning, you find out that the speed with which the water or whatever fluid that is coming out will be like a jet, like those who work in fire service. The jet of water they use in trying to put off some fire incidents. That's why we say jet mixing. We also have static mixing or static mixers and also tubular mixing. Characterization of mixing quality. That is, we want to find out At what point, or how can we achieve and say that we have been able to achieve the quality of the mixing we want? Just like somebody who is doing a titration, you're looking for an endpoint. Depending on the acid and base, and also depending on the indicator used, we can be looking out for a particular color. So when we say when the ultimate of mixing is the carrying out of chemical reaction, then achieve specific rate is suitable measure of quality of mixing, because we're looking at the rate of chemical reaction. Similarly, the achieved heat transfer and mass transfer coefficients are measures of their respective operation, if we're interested in mass transfer or heat transfer. Now, but sometimes various types of tracer techniques can be employed. So if you put a dye, if a dye is introduced, at the time you get a uniform color is noted, and that gives us a high quality of mixing. We can also add a concentrated salt solution, also a color change of an indicator, just like I mentioned in titration. That's what shows us that we have completely achieved what we want, and things like that. We have looked at mixing and agitation, applications of mixing and agitation methods, and characterization of mixing quality. So I hope we have tried to see if I can make, these lectures very short, so we don't have the videos being very lengthy. So thank you very much, and see you in the next class.